Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Muhammad Hilmi Badur Rahman. Today I'm gonna share about network fundamental. So, what is network fundamental? Well, network fundamental is teach the building blocks of modern network design. Learn different types of networks, concept, architecture, and design. Networking fundamentals teach computer science students the building blocks of modern network design. Typically, you will learn about the many different types of networks, networking concepts, architecture, network communication, and network design. Defining a network. A network is a group of two or more computer systems or other devices that are linked together to exchange data. Networks share resources, exchange files, and electronic communication. For example, network computers can share files, or multiple computers on the network can share the same printer. There are many types of computer networks. Common type of networks include the following. First is local area network, or LAN. Computers are geographically close together, that is, in the same building. Second, wide area network, or WAN. The computers are farther apart and are connected by telephone's line or radio waves. The third, metropolitan area network, or MAN, a data network designed for a town or city. Next is home area network, or HAN, a network contained within a user home that connects a person's digital devices. Number 5 is Virtual Private Network, or VPN, a network that is constructed by using public wires, usually the internet, connect to a private network, such as company internal network. And the last, Storage Area Network, or SAN, a high-speed network of storage devices that also connect those storage devices with servers. Okay, that's just the beginning of this. So let's start this presentation. Okay, so about network fundamentals, I'm gonna share to you about all of this. Here we have OC layer 7, then we have TCP IP layer, then we have IP address, and then we have pendalaman IP address, or knowing more about IP address. Next is pembagian kelas IP address, or the classification of IP address. And the last is subnetting. Well, let's go to the first, subtheme, which is OC layer 7. First is pengertian. What is OC layer 7? OC layer 7 is the open system interconnection, or OC layer. Oh, I'm sorry. OC layer, or open system interconnection, is an arrangement or network frameworks that are implemented through network protocol in 7 different layers. History of OC layer. The first to develop this open system interconnection, or OC model, was the International Standards Organization, or ISO, by dividing network communication into 7 layers. Layers 1 until 4 are called the lower layers, which they play a big role in paying attention to the movement of data on the network, as well as layer 5 until 7 called the top layer, which plays as a role in distributing data more widely can be out of the network as well. So this is the structure of OC layer 7. So in layer 1, we have physical. Layer 2, we have data link. Layer 3, we have network. Layer 4, we have transport. Layer 5, we have session. Layer 6, we have presentation. And layer 7, the upper layer, we have application. Well, it's like what I said before. Layer 1 until 4 are called the lower layers, and layer 5 until 7 called the top layers. So we're gonna start with the lower layer first. So 1 until 4. Okay, get out 5 until 7. Let's start with the first layer, the bottom layer, which is physical. What is physical? Physical is a layer to define how a connection can be started, maintained, or terminated. Some protocols in this layer, just like NetBIOS, a session interface protocol and protocol developed by IBM, which provides service to the presentation layer and application layer. NetBUI, NetBIOS Extended User Interface, development of NetBIOS used in Microsoft networking products such as Windows, NT, and LAN Manager, and etc. Next to the second layer, data link. Data link is a layer to determine how bits of data are grouped into a format called as a frame. In addition of this level, there's error correction, flow control, addressing hardware such as media access control address, or we call it MAC address, and determine how network devices such as hubs, bridge, repeaters, and layer 2 switches operate. Next, the third layer is network. Network provide logical addressing and determine the route to the destination. Network layer creates headers for packets that contain IP information, both the data sender IP and the data destination IP. Under certain conditions, this layer will also routing through internet working. And the last layer in lower layer, which is the layer 4, is transport. Transport layer is a layer to break down data into data packets and provide sequence number to these packets so that they can be rearranged on the destination side after receiving. In addition, at this level, it also makes a sign that the packet is received successfully or acknowledgement, and retransmits again the packet lost halfway through. Data transport layer using protocols such as UDP and TCP. Well, that's the lower layer, which is 1 until 4. Now let's continue to upper layer, which is 5 until 7. So 1, 2, 3, 4, you may go. Okay. Let's start with the upper layer first. The second layer, the 7th layer, which is application. Application layer, providing a user interface, is a layer where the interaction of the end user interface with application that work using network functionally, telling how the application works using network resources to then give a message when something goes wrong. Some service and protocols that are in this layer, such as HTTP, FTP, SMTP, and etc. Next, the 6th layer, which is presentation. Presentation is a layer to translate the data that the application wants to transmit into the format which can be transmitted over the network. Protocols that are in this level are devices software, redirector software, such as workstation service in Windows NT and also network shell, a kind of virtual network computing, ENC, or remote desktop protocol. And next, the another upper layer, which is layer 5, is session. Session is a layer to define how a connection can be started, maintained, or terminated. Some protocol in this layer, NetBIOS, a session interface and protocol developed by IBM, which provides service to the presentation layer and application layer. Well, that's the upper layer, and I already tell you about the upper layer and the lower layer. And that's all. Layer 7. Okay, now let's continue to the next subtheme, which is TCP/IP layer. Let's understanding what is TCP/IP. TCP/IP is a data communication standard used by the internet community in the process of exchanging data from one computer to another within the internet network. This protocol cannot stand alone because it is a collection of protocol suite. It is also the most widely used protocol today. In TCP/IP, there is TCP/IP. Let's know about what is TCP first. TCP stands for a transmission control protocol. This is an important core part of the internet protocol. It's often called TCP/IP. TCP provides reliable communication and has a neat order. TCP is on transport layer, and TCP is optimized for communication reliability rather than speed. TCP provides assurance about message delivered from a single computer to another computer. TCP uses a handshake mechanism. TCP/IP, TCP then, now IP. IP, which stands for Internet Protocol, is a network layer protocol, network layer in OC reference model, used by TCP/IP protocol to perform addressing and routing of data packets between hosts on TCP/IP based computer networks. The widely used IP is IP version 4, defined in RFC 791, and it was published in 1981, but will be replaced by IP version 6 at the sometime coming. Okay, we already know about OC layer model last time. This is OC layer 7. So TCP/IP make it like this. From 7 layer into 5 layer only. Let's talk about it. Let's learn about it a bit more. First, the physical layer. The physical layer on the TCP/IP layer is to define the characteristic that hardware is needed to carry the transmission data signal. Things like voltage levels, numbers, and pin interface location defined at this layer. Next is network access. You can see the difference, right? If in OC layer, after physical is data link, in TCP/IP layer, after physical, it's network access. The protocol at this layer provides the media for the system to transmit data to the device, others that are directly connected. The function in this layer is to convert the IP datagram to the frame transmitted by network and map the IP address to the physical address used in the network. This address must be changed to any address required for the physical layer to transmit datagram. Next is internet. Above the network access layer is the internet layer. The internet protocol is at the heart of TCP/IP. And the most important protocols on the internet layer are FC791. IP provides service basic packet delivery on the network on which the TCP/IP network is built. The whole protocol above and under the internet layer use the internet protocol to transmit data. All data at TCP/IP flows through the IP, both incoming and outgoing, ignoring the purpose is left. Next is transport. The two main protocols in this layer are Transmission Control Protocol, TCP, and User Data Stream Protocol, UDP. TCP provides reliable data delivery service with end-to-end detection and error correction, while UDP provides connectionless and low overhead diagram delivery service. Both of these protocols encode data between the application layer and the internet layer. Programmers for application can choose which service are more needed for their application. So TCP is slow, but you can get all the packet. And if there's a missing packet, TCP gonna send it back. While UDP is fast, but you can not get all of your packet. You can only get 80%, 70%, 50%, and you will never get your packet sent back. And the last layer in TCP/IP layer, which is at the very top of the TCP/IP protocol architecture, is the application layer. This layer, including the entire process that uses the transport layer to transmit data. Many one application protocols used today. Some of them are Telnet, FTP, SMTP, DNS, RIP, OSPF, NFS, and HTTP. Okay, we already finished about the layer, OC layer 7 and TCP/IP layer. Now we go to IP address. Let's understand it first. IP address stands for Internet Protocol Address. Is a row of binary numbers between 32 bits to 128 bits that are used as identification addresses for each host computer in the internet network. Bit numbers to indicate the address of a computer on a TCP/IP based internet network. The IP address has a numerical identity that will be labeled to a device that uses the internet protocol as a means of communication. What is function of the IP address? Well, it's used as a host identification tool or interface on the net. The unique IP address will be used to recognize a computer or device on the network, just like someone address that can make you give when you become a career, you can search someone by the address and recognize someone by the address. Next, IP address is used as the network location address to facilitate the delivery of data package. The IP address contains information on its existence. There is a route that must be passed so the data can get to the intended computer. Okay, we done with IP address. But we need to know more about IP address. So let's go to pendalaman IP address, which is mean get to know more about IP address. Well, IP address has so many versions. I mean, no, it's different version and type. Yeah, version. If version, there's two versions of IP. First is IP version 4, or we call it IPv4. Internet Protocol version 4 or IPv4 consists of 32 bit and can accommodate more than 4 million, 4 million to 4 billion to 294,090,67 to 100,096 hosts worldwide. I'm sorry, I'm not really good at doing that. And the next is IP version 6, or we call it IPv6. IPv6 was created to answer concerns about the ability of IPv4 to use only 32 bits to accommodate IP address around the world. The increasing number of internet network users from day to day around the world, IPv4 is assessed will one day reach the maximum limit that can be accommodated, which is why the 128-bit version of IPv6 was created. And this is type, different version and type. For the types, there is two types. First is IP address public, or we just call it IP public. Is an IP address that used in a global internet network, and its use and allocation are regulated by Inter-NIC to ensure the unique use of this IP address. Because this IP address class is used in the internet network, then this IP can access the network internet directly. Devices that use public IP such as web servers, mail servers, DNS servers, Gmail servers, or other devices can be accessed from any network in the world connected to the internet. To be able to use public IP, an organization can usually register with one of the ISP, stand for Internet Service Provider. Next, the second type of IP address is public. The antonym of public is supposed to be private. IP address private. It is called a private IP address because it is IP only recognized and can be accessed from a local network only, and cannot be accessed through the internet network directly without the help of a router that it has a NAT feature. Private IP is used for local networks so that fellow computers can communicating with each other. For example, used in school networks, office, stores, internet cafes, and etc. Devices connected to local networks such as printers, computers, laptops, smart device use will usually get a private IP address. Well, after know more about the version, about the type of IP address, well, we already learned how many. See layer 7, TCP IP layer, IP address, get to know more IP address. Now we go to classification of IP address. Well, so in IP address, there's a classification. So the first is class A. Class A IP has a network count of 126, and each network is capable of accommodating 16,777,214 hosts using prefix 8 until prefix 15. In class A IP address, the highest bit sequence numbers always set with a value of 0, while for the next 7 bits used for complementary, the first octet that works for the network identifier, as for the last 3 octets used for host identifiers. Range IP address class A from 1.xxx.xxx to 126.xxx.xxx.xxx. Next, Class B. Class B IP provides 16,384 networks, and each network hosts up to 65,534 hosts using prefix 16 until prefix 23. The sequence number on the first two bits in the first octet is always set with a value of 10 in a binary number. The next 14 bits are used for complete the first two octets as a network identifier. For the next 16 bits, it works as a host identifier. Class B IP address range from 1 to 8.0.xxx.xxx to 191.255.xxx.xxx. Sorry. Next, Class C. Class C IP address provide 2,097,152 networks, and each network can accommodate 254 hosts using prefix 24 until the maximum prefix 32. And the first three bits on the first octet is always worth 110. Then the next 21 bits form a network identifier. Then for the next 8 bits used for host identifiers. Class C IP address went from 192.0.0.xxx to 255.255.255.xxx. Well, this 3 class is the common class, but there's also 2 class that not get used, not really used. Well, but many people use it. It is class D and E. First is class D. This IP address class is used for multicast IPs. The first 4 bits on the first octet are worth 1110 and at the same time as the network identifier. Then the 28 bits are used for the host identifier. Class D IP range from 224.0.0.0.0 to 239.255.255.255. The next is Class E IP address. Class E IP addresses are used for experiment. The first 4 bits in the first octet of the IP address class are set with a value of 1111 binary numbers and at the same time as a network identifier. Then for the next 28 bits are used for the host identifier. Class E IP range from 240.0.0.0.0 to 254.255.255.255. Okay, we also finished the classification of IP address, and now we go to subnetting. Well, in the subnetting, I'm just gonna show you about the thing that you should know about subnetting. Because subnetting is gonna be like very useful for you as a network engineer. Well, I'm gonna show you the formula of subnetting. Well, in an IP address, we need to find first total IP, second subnet mask, 3 network, 4 initial host, 5 final host or broadcast, 6 gateway, and 7 range. Well, should I show you? Maybe I should show you. Okay. First, to find total IP, let's make IP like 192.168.0.0 10.95 prefix 25. First, if we want to know about total IP, we need to use a total prefix. I'm sorry, I just gonna use we need to make total IP plus the I'm sorry, total prefix plus the prefix. This is, we can see it's prefix 25, so it's gonna be the total prefix is 32. 32. Oh, it's supposed to be minus 32 minus 25 is 7. And then the 7, we must make it become what the name? Yeah, I forgot. And make it become a base. So, oh, I'm sorry. Become a base. So it's gonna be 2 base 7. This is 27, but this thing, it was what the name, it was 2 base 7, and it's this 2 times 2 until 7 times, and it's gonna be what, wait, I forgot. It's gonna be 128. Okay, so it's gonna be 128. So the total IP is 128. Now that was one of the example of searching the subnet. Well, I think that's all for me. Wait, I have to erase all of this. Okay, I think that's all for me. And I hope you enjoy, I hope you understand what I'm saying. Thank you, and wassalamualaikum warahmatullahi wabarakatuh.